In this lesson, we will use a look-at constraint and an expose node to create the core functionality of our twist rig. Before we get started, I'd like to show you the current rig in this scene. I'll go ahead and right-click and grab layers so we can go ahead and hide our arm and armor. So what we have here are a set of helpers, and these have been skinned to the character's forearm. We'll learn skinning shortly. The challenge here is to figure out how to drive the twist of each of these helpers. So right now I'm rotating in gimbal mode just to see the true axis of this object. You can go ahead and set that here. So as we start to drive this in the x-axis, this is the twist axis. This is what we'll need to create an expression for, which we'll take care of in the next lesson. But for right now, we need to create the system that will drive the x-axis of each of these helpers. If I were to go ahead and show the arm, you can see that each of these will affect the skin. Also, just to tell you a little bit more about this rig, each of these helpers have been linked to the forearm. Then I made sure that each of them were then frozen to reset them so we could start at a 0 value, which will make it much easier for us to set up the twist expression. Alright, so what we need to do is create an intermediate object that will affect the twist axis of each of these helpers. And then we'll use an expose node to make sure we grab the correct twist axis to plug into each twist helper. So let's go ahead and get started by creating that intermediate object, and we can create another helper. We could always use another point helper. I'll have the display set to cross because this helper here will overlap this first helper here, forearm A. So we just want to make sure we can select between them easily. So once we've created the point helper, let's go ahead and use Alt-A and align this to our wrist bone in position and orientation. So now we'll go ahead and make sure that this helper here is linked to the forearm, that it's what it should always follow. With it still selected, let's Alt-right-click and freeze its transforms, and now we can rename this to PT twist _L _wrist 01. Okay, let's go ahead and take a close look at this object. You can see that it's oriented to point at the nub of our wrist bone in the x-axis. So this is very important information because when we set up our look at constraint, which we'll do shortly, we can go ahead and make sure that the look at options are correct so that this helper does not shift when the constraint is applied. Alright, well, with it still selected, let's go ahead and grab our move tool. We're going to create an up node object, and that up node object is going to drive the twist axis of this twist object. So holding down shift and making sure that we are translating out locally so that the object will not shift when the look at constraint is connected. Well, again, just go ahead and hold down shift and go ahead and clone this out, just a few units up. And we can go ahead and rename this to PT up VCT L wrist 01. Okay. Now, it might be a good idea to change the display of this object just to discern between each helper. We'll go ahead and set the display to box, and I'll also drop the size here to 5. We'll now want to link this to our arm control so that as the arm control starts to rotate, you can see that the up vector object will always follow. And that will in turn drive the twist axis again of this twist object to make sure that it will always point at the up object. Really neat stuff. Alright, so after we have linked this up object, we just want to go ahead and freeze its transforms. So just in case it were to accidentally shift, we could always move it back with transform to 0. We're now ready to create our look at constraint. So let's go ahead and grab our twist object, PT twist. We'll head over to animation, constraints, and grab the look at constraint, and now we can go ahead and tie that to the wrist nub. You can see it shifted slightly, but we'll cause it to move right back to its original orientation once we assign our up node. So that is not an issue at all. By default, the up node is actually the world up axis. So that's exactly why it is shifted, but that's very simple to change. Let's take a closer look at our look at constraint. So we'll make sure under the motion panel, we're looking under our rotate list, since this is driving the orientation of this object. So here's the look at constraint. What we also see is this line that protrudes from the wrist bone. This is just a way of showing us the direction that this object is pointing in. I like to go ahead and hide this line. We could do that by right-clicking on the view line length parameter to zero that out. So we know that this object is pointing in the x-axis because of the select look at axis option, which by default is x. So that's good to go. Now remember, we wanted to correct the twist axis of this object. It did shift slightly, and that's because currently the up node is set to world. So if we were to go ahead and uncheck this and go to none, if we were to go ahead and select that and now choose the up node as the up object, now you can see that it reverts back to its original orientation. Now, very important here, going to our up node control, right now it's set to axis align, but watch this, if we were to go to our up node object and start to move this around, it's not going to drive that twist axis, simply because our up node control type needs to be set to look at, so this object will look at the current up vector. So now as we go ahead and grab that up vector and start to move that around, take a look, it starts to drive the twist. So again, what that means is when we grab our arm control and start to twist that, notice how it will now start to drive the twist axis of the twist helper. Really exciting. So with the wrist control selected, I'll go ahead and right click and again choose transform to 0 to bring it back. Alright, so guess what? We're now ready to create our expose node so we can search for the twist axis of this helper. So let's go ahead and take a look at that expose node. We find it underneath the create panel and it's right above the point helper under helpers here. So let's go ahead and grab the expose node and just taking a look at its display. Instead of cross, I'll go ahead and set this to axis tripod so we can select between our helpers a little bit faster, so we don't have the expose node overlap the twist helper. I'll go ahead and add it to the scene. Here it is. And now let's go ahead and align it to the wrist. We'll use Alt-A to do that. Align it to our wrist bone. Now something very important to keep in mind about the expose node is that it doesn't matter how it's oriented. That's not what counts. What counts is the information we feed into the expose node. And we do that from the Modify panel right here at the top under the Parameters rollout. So as of right now, it's assigned to nothing. But watch this. If we were to go ahead and click on None, and now click on the Twist Helper, notice it has been assigned. We could see its parent object, which is very important, because now we can go ahead and take a look at its local data. Here it is, the local Euler channels. Here's the x-axis. It's zeroed out. But now we can go ahead and take this x-axis and plug that into each twist helper here for the forearm. Let's go ahead and pin this expose node down and take a look at the x-axis as we start to move our up object. You can see how it starts to change and update. So this is great because as it starts to twist around, you can see that as that information will change, that will in turn cause the twist axis of each twist helper to also change the way we want them to. Alright, great. So, what I'd like to do is go back to the expose node and rename it. That's going to be expose underscore L underscore wrist 01. Alright, so now that that's done, we can go ahead and finish up our twist rig in the next lesson by creating a set of expressions to create our twist distribution.